Hello and welcome. We are here today at NASA headquarters in Washington, D.C. for a press briefing on a report from an independent study team on unidentified anomalous phenomena. We have 4 speakers here today. We have Bill Nelson, our NASA administrator, Nikki Fox, the Associate Administrator for the Science Mission Directorate, Dan Evans, the Assistant Deputy Associate Administrator for Research within the Science Mission Directorate, and David Spergel, who is the president of the Simons Foundation and was also the chair of this particular independent study team. I will ask everybody in the room to please silence your cell phones. We will get started with everybody giving a few opening remarks, and then we will take questions. We will take questions both in the room and then from the phones. And for now, I will hand it over to the administrator.
Thanks so much, and thanks for coming today. NASA searches for the unknown in air and space. It's in our DNA. From digging on Mars with the Perseverance rover in those little titanium tubes that we intend to go back and pick up, digging in a dry lake bed near the mouth of a river. Now we're going up to the top of the cliff where the scientists feel that there could be the best examples of if there were life there millions of years ago. Whether we're dealing with Perseverance or the James Webb Space Telescope, which searches for exoplanets with signs of habitability, we are looking for signs of life, past and present. And it's in our DNA to explore and to ask why things are the way they are. In June of last year, NASA commissioned an independent study team to examine unidentified anomalous phenomena. We did so with a few goals in mind. First, to examine how NASA can use our expertise and instruments to study UAP from a scientific perspective. Second, shift the conversation about UAP from sensationalism to science, and to make sure that whatever we find or whatever we recommend, to make sure that information is shared transparently around the world. There's a global fascination with UAP. On my travels, one of the first questions I often get is about these sightings. And much of that fascination is due to the unknown nature of it. Think about it. Most UAP sightings result in very limited data. That makes it even more difficult to draw scientific conclusions about the nature of UAP. And so this independent study team brought together some of the world's leading scientists, data, and artificial intelligence experts, aerospace safety specialists, all with a specific charge from me, which is to tell how to apply the full focus of science and data to UAP. And this is the first time that NASA has taken concrete action to seriously look into UAP. And this independent study team was just that, independent. Now, NASA has a statutory authority to look for life in the universe. And when you think of the universe, and especially what we have learned from the James Webb Space Telescope, how vast that it is. We knew before, and it was a NASA scientist, Dr. John Mather, who got the Nobel that determined that the universe was 13.8 billion years old. And over the years, particularly accelerated in the last century, we have an understanding that, of course, ours is not the only galaxy. And there are billions and billions of galaxies, and each of those galaxies, including our own, have billions and billions of stars. And with the James Webb looking at the exoplanets, we are now beginning to discover, and somewhere out there, we will discover another medium-sized stony planet around a medium-sized sun or star at just the right distance, not too far, not too close, with a tilt in its axis that rotates, that has carbon, that will have a habitable atmosphere. If you ask me, do I believe there's life in a universe that is so vast that it's hard for me to comprehend how big it is? My personal answer is yes. But I asked some of our scientists. As a matter of fact, the Washington Post editorial board asked us to come down to the question, what is the mathematical probability that there is life out there in the universe? And if you calculate in billions of stars, in billions of galaxies, that there's replicated what I just said, another stony planet. The answer was, what's the likelihood? At least 1 trillion. That's from our scientist. So we start this without any preconceived notions, but understanding that we're in a world of discovery. And we, NASA, have taken for the first time concrete action to seriously look into UAP. And this independent study team is exactly that. It's independent. They work to develop recommendations about how NASA could better examine them from a scientific perspective. And the top takeaway from the study is that there is a lot more to learn. The NASA independent study team did not find any evidence that UAP have an extraterrestrial origin, but we don't know what these UAP are. That's why I'm announcing that NASA has appointed a NASA Director of UAP Research. They are being tasked with developing and overseeing the implementation of NASA's vision for UAP research. We will use NASA's expertise to work with other agencies to analyze UAP. We will use AI and machine learning to search the skies for anomalies, as we have been searching the heavens and will continue to search the heavens for habitability. And NASA will do this transparently. So while today is a significant step for NASA, it's certainly not our final step. And we're going to share more with you, and I want to introduce you to Dr. Nikki Fox, who is the head of our Science Mission Directorate. Nikki.
Good morning, and thank you so much, Administrator Nelson. It's always tough to follow Bill. He's such a great speaker. But I want to thank the independent study team for their amazing service on the study and for their continued contributions towards the advancement of our nation's understanding of unidentified anomalous phenomena. UAP, as Bill just eloquently said, UAP are one of our planet's greatest mysteries, and it's really due to the limited number of high-quality data that surrounds such incidents and often renders them unidentifiable. While there are numerous eyewitness accounts and visuals associated with UAP, they're not consistent, they're not detailed, and they're not curated observations that can be used to make definitive scientific conclusions about the nature and the origin of UAP. The language of scientists is data, and data points towards a scientific conclusion to what the nature and the origin of UAP could be. That leads us to why we're here today. The independent study team's report is now public, and it can be found at science.nasa.gov/UAP. While NASA is still working to evaluate the report and to assess the independent study team's findings and recommendations, NASA is committed to immediately contributing to the federal government's unified UAP effort, and as you heard, we have appointed a director of UAP research. In their role, they will centralize communications, resources, and data analytical capabilities across the federal government to establish a robust database for the evaluation of any future data. Additionally, our Director of UAP Research will also leverage NASA's expertise in artificial intelligence, machine learning, and space-based observation tools that will support and enhance the broader government initiative into UAP. They will serve as NASA's point of contact for government entities, but especially for the All-Domain Anomaly Resolution Office, or ARROW. And this will ensure our coordinated efforts and effective communication channels. Beyond our Director of UAP Research, NASA will also advance citizen reporting by working with the public and commercial pilots to collect a broader set of data to add to the vast data repositories to not only contribute to a broader, more reliable data set for future UAP incidents, but to also contribute to the destigmatization of the important study of UAPs. And with that, it is my great pleasure to hand over to Dr. Dan Evans, who is the NASA official responsible for supporting this amazing study.
Good morning. I'd like to begin by expressing my sincere thanks to NASA Administrator Bill Nelson for directing this study. We at NASA believe that understanding UAP is vital for several reasons. First and foremost, it provides an opportunity for us to expand our understanding of the world around us. At NASA, we are committed to charting the uncharted, so this work aligns with who we are. Secondly, this study aims to enhance situational awareness. The presence of UAP raises serious concerns about the safety of our skies, and it's this nation's obligation to determine whether these phenomena pose any potential risks to airspace safety. Let's not forget that the first A in NASA is aeronautics. So by understanding the nature of UAP, we can ensure that our skies remain a safe space for all. Administrator Nelson directed us to put together an independent and external team of world-leading experts to produce a report containing a roadmap with a series of recommendations that describe how NASA could best help in the cross-government response to UAP. Months of meticulous fact-finding, cross-disciplinary collaboration, and scientific rigor gave the team insights that will greatly enhance our nation's understanding of UAP going forward. The team's report, now available on NASA's website, stands as a testament to NASA's and the team's commitment to transparency, to the power of science, and to the unwavering quest for knowledge. We at NASA believe that studying UAP represents an exciting step forward in our journey to uncover the mysteries of the world around us. By embracing a scientific lens, we have ensured that our work is evidence-based and data-driven, and by valuing transparency and openness, we have aimed to foster trust and collaboration with the public. I'd like to conclude by extending my deepest gratitude to the team for their incredible dedication and service. Their efforts have been instrumental, and I truly appreciate the expertise and commitment that each of them have brought to this endeavor. And with that, I'll pass over to Dr. David Spergel, who chaired our study.
Well, first and foremost, I'd like to extend our sincere gratitude to the NASA Administrator for entrusting us with this pivotal study. Your faith in our capabilities has been a driving force behind the panel's approach. The panel's comprehensive study into unidentified anomalous phenomena, or UAP, has led to several crucial findings, and I'd like to elucidate on our methodology and those findings this morning. We began by rigorously assessing the current state of UAP data. Our goal was not to repeat the work of the ARROW, but to understand the nature of the reports. Our goal was to produce a roadmap for NASA to contribute to the understanding of the nature of UAP events. We looked at NASA's assets. While they provide a comprehensive picture of the ocean, the Earth's surface and atmosphere for studying our evolving planet, they typically do not have the resolution needed for UAP events. However, by providing data on environmental conditions, they can complement other data on UAP. The current approach to UAP data collection has led to a limited sample of events and limited data. Stigma has limited reporting by pilots, both civilian and military, so we know there's missing data. For its analysis in other areas, NASA always takes a scientific approach of systematic data collection that involves calibrating instruments, multiple measurements, and ensuring sensor metadata. Most UAP events lack this quality of data. One of NASA's contribution to the broader governmental effort to bring these methodologies to create a data set is to bring these methodologies to create a data set that's both reliable and extensive. And once we have a large sample of well-characterized events, AI and ML tools, which are proving to be powerful in so many other applications, will likely prove helpful in identifying interesting anomalies. It is essential to clarify, based on our current findings and methodology, that we find no evidence to suggest that UAP are extraterrestrial in origin. Our focus is on understanding the phenomenon, however, regardless of the source. And previous work from the ARROW has shown that most events are explainable as planes, balloons, drones, weather phenomena, and instrument features. And in any search for interesting anomalies, the first step is to eliminate the chaff of conventional events before moving on to identify novel phenomena. In this, the public's role cannot be overstated. The panel envisioned a framework that leverages crowdsourcing, possibly via smartphone applications, to capture a broader spectrum of data, ensuring more eyes and ears on the ground. Lastly, we delved into the safety concerns UAP present within U.S. airspace. By integrating UAP collection within our current aviation reporting system, the panel believes we can provide insights into potential safety risks. NASA can reduce the stigma associated with pilots reporting anomalies, and fundamentally, by studying events we don't understand, we advance our understanding. So in conclusion, with a rigorous methodology, collaborative efforts, public engagement, NASA can be a key player in the whole of government approach to understanding UAP. Thank you.
Thank you so much to all of our speakers. We will start taking questions. For those in the room, we have a microphone over here that we would ask you to speak into. We will also be alternating with questions from those on the phone line. For those of you who are in the phone line, please press *1 to get onto the queue. We will try to answer as many as we can today. We'll see how it goes. Please, sir.
Thank you very much. This is directed to Mr. Nelson. Thank you for being here. Two quick questions. One is, how can we make the determination of what something isn't when we don't know what it is? And B, after a careful review of the data, if it's determined that some, underline the word some 10 times, UFOs or UAP originate from a non-human intelligence, what's the plan to disclose that to the public?
And can you identify yourself, please?
James Fox. Thank you.
I'm sorry, and what outlet?
Independent media. Thank you.
Well, let me repeat.
It's on.
Let me repeat what I said. I think it's important that you hear this word for word. The NASA independent study team did not find any evidence that UAP have an extraterrestrial origin, but we don't know what these UAP are. The mission of NASA is to find out the unknown. I've said several times in my comments here today that we, NASA, deal openly, and we will be transparent on this. And we're trying to address the question of there's so much concern that there's something locked up, classified, and that the American government is not being open. Well, we are the American government, and we are open, and we're going to be open about this. We don't. Again, I'm going to repeat that statement. but we don't know what these UAP are. But we're going to try to find out.
Thank you very much. And is there a plan in place if it is determined that some of them represent or originate from a non-human intelligence to tell the public? Is there a plan or?
If we are what I said we intend to be, which is transparent, you bet your boots. We will say that. And I've tried to set the table for you by telling you what I personally believe in a universe that is so vast that could there be a replication of life on Earth elsewhere in another solar system that is so big? Of course I believe that. The distances, it would have to be a very advanced civilization. The distances, you know, light years, hundreds of light years, billions of light years. But whatever we find, we're going to tell you.
Thank you very much.
Great, and we'll move on to the next question. Please do identify yourself.
Thanks. This is Joey Roulette from Reuters. Question for Bill Nelson or any of the other panelists. So you've appointed a director of UAP research. Have you named someone to that role? And what kind of investment are you considering making in this? Is this going to be a new program office? Have you thought of funding figures, et cetera? Thanks.
Yes, we have. We've already appointed the person. They've been working there for a while now, like during the study, to help be a point of contact. And you know, any budget discussions, of course, are part of a very intricate federal budget request, and so they're not something that we discuss openly. But we will certainly look at what resources need to be allocated.
Can you name the official who's in
We
that
will
role?
not give his name out, no.
Okay, thanks.
Thank you. We'll take another one from in the room.
Hello, Dan Rivers from British broadcaster ITV News. I heard the word stigma mentioned several times, that you want to remove the stigma. Is your message to pilots and other people that this is no longer the preserve of cranks and that you won't be laughed at and that you will take them seriously? Is that the takeaway?
That is exactly the message. I mean, at NASA, we're scientists. We love data. We love all data. And if there is something that needs to be reported, and we want people to be able to feel that they can report that. You know, we spoke in the open hearing that we had here just a few months ago. Dan, remind me when it was?
May 31st.
May 31st. And we actually talked then about we wanted to remove the stigma, and we also did not tolerate any of the abuse that some of our members of the panel were receiving, particularly on social media, for doing this really important scientific study. So absolutely, we want pilots and both, as Bill said, you know, both private pilots, commercial pilots, military pilots, to feel that if they see something, they need to report it.
I want to say, and I want to repeat the way I said it, we want to shift the conversation about UAPs from sensationalism to science.
I think of this in terms of the signs we see around for security, which say, if you see something, say something. I think in this context, we would summarize it as, if you see something, collect high-quality data on it, because then we can learn.
If I may, I just noticed in the report the Go Fast incident was one that was picked out, and that had been held up as an example of a very credible sighting that you seem to be pouring doubt on. Can you just talk to that?
I mean, we looked at that as one example, and you know, I think this is something that Arrow has actually done a very good job of going through the events. And most events are going to turn out, even if there are some events that in the end turn out to be something novel, most events are going to turn out to be conventional things, balloons, airplanes, and so on. I think of the process of discovery of anomalies as looking for a needle in a haystack. And if you want to find a needle in a haystack, you've got two choices. Either you know exactly what the needle looks like, and you design a very good filter to look for the needle. It's called match filtering in sort of AI work. machine learning, stigma processing. Or you don't know what you're looking for. And with anomalies, that's really the case we're in. We're looking for things we don't understand. So if you want to find something strange in a haystack, you better know exactly what hay looks like. And you better be able to characterize that really well. And that's why in a process like this, and this is something that I think we bring to this as we look for anomalies, is you need to know what typical regular things look like under all conditions. You need to know what balloons look like when pilots see them, so under unusual conditions, so that you can eliminate those events. And that's why in identifying anomalies, understanding the normal is a very important part of it, and understanding that under different observing conditions, and collecting data in a uniform way. I mean, this is what we do when we study anomalies in space science or other areas of science. And what we're trying to do is bring this approach to this field by saying collect high quality data, understand the normal events, and that's how we move things forward.
Thank you.
We'll move on to the next question, please.
Hello, I'm Nomia Iqbal from BBC News. Just to follow up on the stigma question, UAP, that term has been used in part to destigmatize UFOs. The fact is most people use UFOs. Most of the American public, most of the world use that term. So I wonder how much is the stigma still a problem for you, and what are you practically doing to about it, really, to convince people? And my second very quick question. In your report, I noticed that you said AI is a very essential tool for identifying rare occurrences. Yesterday, we were at this big AI summit where you had 100 senators meeting all the big tech tycoons, Elon Musk, Mark Zuckerberg. And speaking to some senators afterwards, they said, we are concerned about AI, we need it to be regulated. Does that concern you? Are you worried that it might hamper your work? Thank you very much.
Well, two big questions. First of all, do I personally believe that AI needs to have some boundaries? The answer to that for our existentialism, yes. Can you do that within the appropriate bounds so that, as I said in my remarks, that we're going to utilize AI as one of the tools as we search for what is an answer to the UAP. And so no, I don't think that any attempts that the Congress has underway to try to write a law that would appropriately put guardrails around AI for other reasons is in any way going to inhibit us from utilizing the tools of AI to help us in our quest on this specific issue. Now, what was your other question?
Just how do you destigmatize the whole thing? Because I know you call it UAPs, but people don't refer it to in that way.
Yeah. Well, there's a mindset. We all are entertained by Indiana Jones in the Amazon and finding the crystal skull. So there's a lot of folklore out there. That's why we entered the stage, the arena, to try to get into this from a science point.
I think you can blame the X-Files for a lot of this as well.
That possibly too, but just remember what I said. We NASA are trying to shift it from sensationalism to science.
Okay, thank you very much.
Yes, ma'am.
And we do have a long line in the room, but I want to give a couple chances to some people on the phone line, so I'm going to go to the phone for our first question there. Please do introduce yourself and ask your question. The phone, can you hear me?
Our first question is from Marcia Dunn with the Associated Press. Your line is open.
Yes, hi, Marcia Dunn, AP. I'm already receiving emails on Area 51 in Roswell, so I would like to ask Mr. Spergel, how much were you and your fellow panel members hassled or bombarded by this sort of thing during the course of your study? And for NASA, are you not naming the director of UAP research for this very reason, so that they're not hassled and bombarded by the fringe element? Thanks.
I would divide kind of emails and tweets into two types, right? There's some where people honestly are curious about things they've seen, they've heard. There are things that are hard to respond to, like my uncle who's dead saw something strange, and you get a report. And that's not useful, but that's harmless. On the other hand, one of the things that happened during the study, and this may be part of a bigger discussion of cultural behavior on social media, where people behaved badly, and I would say harassed some of our panel members. And that, I think, was very inappropriate behavior one doesn't want to see. Sadly, I think it's part of a deeper problem when people somehow feel on the web, on social media, they can be nasty and hostile, and sadly, some of our panel members experience that.
Yeah, I would just simply add to that to say that not only were some of the things that our panel members received during the course of this study simple trolling, some of them actually rose to actual threats. And as a result, we at NASA take the sanctity of the scientific process and the security and safety of our team extremely seriously. And yes, that's in part why we are not splashing the name of our new director out there, because science needs to be free. Science needs to undergo a real and rigorous and rational process, and you need the freedom of thought to be able to do that. Some of the threats and the harassment have been beyond the pale, quite frankly, towards some of our panelists. And yes, it's important that science be free as part of that process.
Thank you so much. We will go to another question on the phone, please. Please go ahead and introduce yourself.
Our next question comes from Tom Clark with Sky News London. Your line is open.
Oh, hi there. Thank you very much for taking my question. I want to understand how much, you won't give us an idea of money, but how many assets or new research programs will be devoted to this by the administration. Because it strikes me that although the argument for aviation safety is clear, there are other departments and agencies responsible for that particular thing. And as the report concludes, the likelihood of there being extraterrestrial explanations or truly scientific explanations for many of these phenomena is very, very small. Shouldn't NASA devote its research budgets and its efforts to those much more likely and tangible signs of extraterrestrial life through things like the James Webb Space Telescope or extrasolar planets detection?
Yeah, thank you for the question. So yes, obviously we don't discuss budget openly, but we are committed to supporting the whole of government study into UAP. All of our data are open. In fact, if you look at the report, you'll see a very large sort of background material or supplemental material in there, because we literally released everything, because that's what we do at NASA. We do have our key agency goals. We have obviously our goals in the Science Mission Directorate, our themes that we follow, and one of those, as the administrator described, is the search for life elsewhere. And we do that, and he described the research beautifully. I think he may be going for my job, actually, but he described the research so well that what we need to find is a rocky planet around a hospitable star that isn't too violent, that is in just that right place, that has signatures of water and signatures of carbon, so the building blocks of life. And we continue to strive to do that. We do that with the James Webb Telescope. We'll be doing that when we launch the Nancy Grace Roman Telescope, that even has a coronagraph around it to block out the light of the neighboring stars and really let us look at those possible planets. And then beyond that, the next big telescope recommended by the Astrophysics Decadal is the Habitable Worlds Observatory, actually a mission designed to look for hospitable and find like Earth 2.0 in another stellar system. And so they really are in the forefront of our goals at NASA. So thanks so much for the question.
I'm going to ask...
Just jump in to clarify something. Will you be devoting any new resource or research projects to this particular aim then, given that's where the interesting questions really are? Should NASA spend time and budget pursuing the much less likely task of finding signs of extraterrestrial life in small objects within or close to the Earth's atmosphere?
So, I mean, most of obviously our instruments are designed to look for the phenomena that we study at NASA. If any of our data are useful, if any of our data are applicable, then we absolutely will be devoting that and turning that over through our liaison to the whole of government approach. We are not at this time intending to design a mission to do this. That is not part of our kind of overarching NASA direction. We are looking at providing some research support. So if somebody wants to write a research proposal, send it in through the regular channels. We will be looking for ways to do that. And we also talked about supporting sort of the citizen science and the broader like repository of data. Dan, do you want to add to that?
NASA's data are free and publicly accessible for the entire world to download. And we pride ourselves on that fact. And it's this openness of data and our approach, which is why we're all here today. To answer your specific question about devoting research budgets to the potentially truly interesting ones, well, I think as David said, you have to understand the chaff in order to really understand and pinpoint the potentially interesting ones, okay? So we are in such a data-poor regime at the moment that we need to turn it into a data-rich one to do that. And we employ NASA's assets, many other partners' assets as well in that quest.
And if your question suggests, and I do not know that it does, but if it suggests that NASA ought to keep its nose out of this, well, let me tell you, NASA is not a place that's going to hide its head in the sand. Now, is there interest in this phenomenon in other agencies? In my previous life in the Senate, I was privy to talk to the Navy pilots and to see the video of what they encountered off the coast of California in 2004. That was in a classified setting then. But this is now, and you have now seen that video, and you have heard from those former Navy pilots. Is that of a concern to the Department of Defense? Of course it is. Therefore, we're going to continue our search from a scientific point of view. It's going to be, if those other agencies continued their search, we're going to be glad to join in with them. But our stuff is going to be open.
Great. I'm going to take one more from the phone before we go back to the floor. We have a lot of questions. I'm going to hope we can stick to sort of one per person and see how many we can get through. So one more from the phone, please.
Our next question comes from Jeff Faust with Space News. Your line is open.
Hi. I know the press release states that NASA is still evaluating the independent study team's report and its recommendations. Does NASA plan to publish a formal response to the report and its recommendations? And if so, what timeline can we expect to see that?
So let me give you a quick preview about how this works. So we have only very, very recently received the report, and what you have seen today in our press release represents our initial actions in recognition of the urgency of this matter. And yes, we will be following up as appropriate with additional actions. But of course, we need additional time to fully ingest the recommendations and act on them in light of budget and many other priorities. But we'll be announcing more in the future.
Great, thank you. Please, back to the room. Identify yourself too, please.
Good morning, Sam Cabral with BBC News Digital. We've been talking a lot about shift from sensationalism to science today. Has NASA been in touch with the Mexican authorities about the rather sensational revelations earlier this week of 2 allegedly non-human corpses? And what, if any, importance do you attach to these discoveries?
I think David had a prep for that one.
Well, this is something that I know I've only seen on Twitter. So it's, when we have unusual things, you want to make data public. I think of this as like NASA has one of the most valuable samples from outer space, lunar rocks. What do? We make them available to any scientists who want to work on this. We don't know the nature of those samples that were shown in front of them. If I was the Mexican government, I would are making recommendations to the Mexican government. That's not our charge here. We're doing this for NASA. My recommendation was, if you have something strange, make samples available to the world scientific community, and we'll see what's there.
I'll just add that one of the main goals of what we're trying to do here today is to move conjecture and conspiracy towards science and sanity, and you do that with data, as David says, and that's the whole purpose of this study and this roadmap.
Thank you.
Thank you.
Hi, Brandy Vincent from Defense Scoop. Thank you all for doing this. I actually have 2 lines of questions, if it's okay. First, for Ms. Fox, what's the timeline and immediate actions that NASA is pursuing specifically with ARROW now that the report has been completed? And what mechanisms are NASA and DoD really using to share information and collaborate securely? And do you see more coming? And then separately, for Mr. Spergel, I noticed in the final report a lot of the images and media that were added were from DoD, snapshots that we'd previously seen from DoD data. Not much from FAA, if anything, not from other agencies. Can you speak to why that is and what all you used beyond DoD to inform your report?
Dr. Fox, Dr. Spergel, I'll pass it to you guys.
Sure. So, yes, our immediate actions, I think there was such a lot in those questions. So the immediate actions, we've established our director of UAP research. They're working across the whole of government. They're working very closely with ARROW. They are the sort of central point for all of the collaboration. I'm not sure what else you asked, I'm sorry.
What mechanisms are you using to share data and information with the Defense Department?
All mechanisms available to us. As Dan eloquently said, all of our data are open and public. So actually, I mean, we share everything with everybody, so everybody can access our NASA data.
I mean, do you have like a specific repository or mechanism or channel specifically with DoD where you're sharing information? Can you just expand a little on how ARROW and DoD are working? So ARROW and NASA are working so deeply to share things.
Sure. Do you want to take that?
Yeah, sure. I'm happy to handle that. Yeah. So as Nikki beautifully said, all of NASA's data is open and accessible to the public. If DoD on a specific instance need to tap our expertise, then there are obviously secure ways of doing that, and we've done that by appointing our liaison officer. And yes, we know how to talk to DoD in a classified space. But again, most of what we do is unclassified, and for good reason.
And the answer is actually straightforward, that ARROW is the lead agency in the government. So FAA reported events go to ARROW. Mm-hmm. So they're the central collection agency, and that actually, if you go to the ARROW site, they have a pretty complete list of things they've analyzed and are trying to make public. Though with ARROW, and this is just something I think is worth repeating in the context of looking at images that come from military satellites and intelligence community. It's important to remember that images taken by military instruments are classified, not because of what's in the image, but because of the nature of the measuring instrument. And I think this is one of the unique things that NASA brings here, is NASA is about openness and transparency. When NASA makes measurements, NASA has across all of it does, this program of making its data open and available. And of course, because it's not making measurements with classified instruments, that enables it to do this. And that one of the things that NASA brings to this space.
Thank you. And just a really quick clarification, because I think it's important. The NASA Aero Liaison, is that official the same as your new UAP head of research?
Yes.
Okay. Thank you.
All right, one more in the room before we go back to the phones for a couple.
Thank you. My name is Jacob Jensen. I work for a Danish newspaper called Berlingske. My question is for Mr. Nelson. You said at the beginning of the meeting that that NASA will be transparent. Well, a month and a half ago, Mr. David Grush said under oath in Congress that the U.S. government is in possession of UAPs and extraterrestrial life. How can you be sure at NASA that other parts of the U.S. government is being transparent?
I don't speak for other parts of the government, but I can tell you NASA, which I speak for, is open and transparent with our data.
Do you believe what Mr. David Grush said, or is he lying?
You would want me to give a personal opinion?
Yes, please.
Of what he said. What he said, if I recall having seen this on the nightly news, was that he had a friend that knew where a warehouse was that had an UFO locked up in a warehouse. He also said he had another friend that said that he had parts of an alien. Whatever he said, where's the evidence? Is my response.
Excuse me. He also said that he did interview over 40 employees at the Pentagon.
Long time ago, there was a TV show, Jack Friday, and he used to say, just the facts, just the facts. Show me the evidence.
Thank you, sir.
All right, we will go to the phones. Again, I know people have lots of questions, but I'm going to try to keep us to just to one for each person. And so next person on the phone, go ahead and introduce yourself.
The next question comes from Gina Cesari with ABC News. Your line is open.
This is for Senator Nelson. Your report mentioned that AI could be very useful in helping in this investigation. How do you see that, sir?
Well, why limit us in anything in interpretation of data? And AI is just coming on the scene to be explored in all areas. So why should we limit any technological tool in analyzing data that we have? I said AI was one of the things that we were going to employ.
I mean, we use AI, or artificial intelligence and machine learning throughout our NASA science portfolio. It is an amazing tool for helping us to actually find often signatures that are sort of buried in data. And so a lot of our data are just sort of wiggly line plots. We get excited about wiggly line plots, by the way. But sometimes you see the wiggles and you miss a signal in there. And by using artificial intelligence, we can often find signatures. So one example we've had is to be able to find signatures of superstorms using very old data that really is before sort of like routine scientific satellite data. And it's amazing. And so just being able to use those techniques often can allow us to find things, to actually find the needle. As David so eloquently said, once you've actually really it also helps us to really characterize the hay. And so you can start subtracting the hay and look for the needles behind.
So let me just take this moment to try to demystify AI and ML.
Thank you.
When, as scientists, and probably many of you in high school were trained to do this, we had some data. You took your data, you drew a graph, you put a line through it. You had data in 2 dimensions, X and Y. Right now, much of our data is in a much higher dimensional space. And if you're working with something like ChatGPT, it's in a high dimensional space of language, or tokens, if you want to get technical, with 12,000 tokens in the ChatGPT 3.5, for example. And machine learning is a powerful tool for representing functions in high dimensional space. That means we get to work with data in a high dimensional space. AI is very powerful, but it's no more powerful than the data you give it. It's a way of, this is why it's very powerful, say, with NASA's weather and climate data. We've got an incredible amount of data, and it's data that you want to do more with than just put a line on a graph. You want to extract all that information or more information in that high dimensional space, and I think we're just really discovering the power of that tool, and it's one of the tools NASA and not just scientists, but I think a lot of people in a lot of different industries are using to learn new things about high dimensional data. But it always comes back to the data you feed into your analysis, whether it's a line on a graph paper or a high dimensional space explored with machine learning. And if you don't got good data, you're not going to learn things.
I'm going to add one sentence. Sorry. High dimensional does not mean high space dimensions, not interdimensional travel. We're talking about multiple parameters here. Okay. Erin.
Great. We are coming close to time. I want to get 2 more questions, and we're going to do one on the phone and one more in the room. And hopefully, if we keep our questions short and our answers short, we'll get to those 2. For anybody who's here who hasn't had a chance to ask a question, you are more than welcome to send an email, and we will try to get you answers as quickly as possible. So one more on the phone, please.
Yes, our next question comes from Peggy Holliger with Financial Times. Your line is open.
Thank you very much, and thank you for allowing me to ask a question. I'm curious about you saying here that you want to rope in crowdsourcing, but also you speak specifically about the potential of using commercial assets as well as your own. I'm curious about, can you just give me a bit more detail how you will do that? Will that be through commercial contracts, or will you ask for voluntary reportings of sightings? And also, I think that's when you talk a lot about the importance of sensor, I'm going to use the word harmonization, because there's no kind of harmonization between the way the sensors work. Presumably, that would be the same for the use of commercial assets. How does that use of commercial assets and crowdsourcing square with the sensor harmonization that you talk about? And who's going to pay for all this? Thank you.
So let me just say a little bit about crowdsourcing. Much of what we have in mind is taking advantage of the fact that there's several billion of these floating around, right? And they take, I'm holding up a cell phone for those on the radio. They take wonderful, high-quality images, have high-quality metadata, record local magnetic field, sound, gravitational field. There's a wealth of data that a cell phone takes, and you can imagine designing apps that make the images relatively tamper-free. You can at least make it hard to do. And I think if we have a collection where interesting events are collected by citizens, hosted, and you have multiple images of the same event, we will be able to learn a lot. And one of the things NASA supports is citizen science. And I think that the idea that if you see something you don't understand, collect data, we aggregate the data and we learn from it, is important in this context, and just, I think, in some ways, an opportunity to engage the broader public in doing science.
Great. Our last question, please, from the floor.
Thank you all for doing this. Joe Khalil with News Nation. My first question is, you've described harassment of some of the panelists. While that is horrible and never a good thing, it does sort of come with the nature of public officials. You know, Mr. Nelson, as senator, lawmakers get that kind of thing all the time. Is that the justification for keeping this new position, director of UAP research, private? Do you plan on doing that forever? Is that a temporary thing? Because it seems to cut against the dedication to being open and transparent if this person forever is not going to be revealed, their identity, who they are.
Yeah, okay, so at the time, yes, we are withholding that name. Let's not forget that we've only just received this report. And what we need to do now as an agency is come together and provide a cohesive and coherent response to it that addresses multiple findings and recommendations, okay? We're only announcing initial actions today. Will that person's name be disclosed to answer your specific question? Potentially, yes. But again, we need to ensure that the scientific process and method is free, okay? That's my response.
Thank you. And just lastly, the report says that you relied on unclassified material. You've given a very understandable description for why the DoD classifies certain images and videos. Why did you all not have access to classified material, and could you have, done that?
I have. So just understand that. Let the committee speak for themselves.
So one of the reasons that we restricted ourselves, this study, to unclassified data is because we can speak openly about it. And in so doing, we're aiming, again, to alter the discourse from sensationalism to science, as Administrator Nelson beautifully said. NASA personnel, as appropriate, know how to talk to DoD on a classified basis, but the purpose of this study was to tell us what open data we could use in combination with the power of science to move our understanding forward. Okay? That was the purpose, and we're speaking about it openly today.
And so one of the challenges
And I'm afraid we do have to wrap up. We are at time. So thank you, everybody, for being here today. Again, for those people who were not able to get questions, I do apologize for not doing it in the room. However, please send an email based on our press release. You will have information to access, and we will try to get you the answers we can. And with that, we're concluding today's press briefing, and thank you very much for being here.
Thank you.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.
We have been given the scientific knowledge, the technical ability, and the material to pursue the exploration of the universe.
I'm Christina Cook. I'm a mission specialist.
I'm Jeremy Hansen. I'm a mission specialist.
I'm Victor Glover. I'm the pilot.
I'm Reed Wiseman. I'm the commander for the Artemis II mission to the moon.
To the moon.
To the moon.
To the moon.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. It's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign and missions have set such an ambitious goal for humanity that it's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together.
When I look at the Artemis 2 crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is so cool to be around them. Artemis 2 is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on our moon.
Before steam engine start.
Artemis 2 will be NASA's first crewed flight test of the Space Launch System rocket
and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
and pave the way for NASA's long-term human and scientific presence
on the lunar surface.
We are ready.
We are going
to the moon
for all humanity.
We are Artemis.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science. It holds opportunities for us to make discoveries about our home planet, about our sun, and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts.
And we will expand the logistics supply chain to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Let us continue to dream the impossible dream that now becomes real.
Space is for everyone. We humans really are connected to the universe.
The Earth's climate is changing. We have documented the changes.
And we have touchdown!
And liftoff. The Starliner is headed back to space on the shoulders of Atlas.
The Artemis generation stands ready to return humanity to the moon and then to take us further than ever before to Mars.
Through Artemis, the twin sister of Apollo, we are returning to the moon. This is Orion, the only human-rated spacecraft in the world capable of deep space travel. And now, the Space Launch System, NASA's most powerful rocket since the Apollo era, stands ready. Having undergone and passed numerous tests, the time has come to complete the journey. With hardware originating from every state in the nation and from partners around the world, Artemis 1 will be the first flight test of each of these components now assembled together. These two solid rocket boosters will provide more than 75% of the thrust necessary to leave Earth. Each booster stands 17 stories tall, a full segment more powerful than the SRBs of Shuttle. Together, these boosters are capable of 7.2 million pounds of thrust and will burn for the first 2 minutes of flight. The core stage, at 212 feet, is the tallest rocket stage NASA has ever built. With the rocket's flight computer secured inside, the core stage is designed to hold 2.3 million pounds of fuel. The 196,000 gallons of liquid oxygen and the 537,000 gallons of liquid hydrogen will combine to provide 8.5 minutes of propellant to the 4 massive RS-25 engines mounted below. As proven workhorses of the shuttle fleet, each RS-25 engine has a legacy all its own. Together, these 4 engines provide 2 million pounds of thrust, and with the SRBs, are capable of pushing Orion to a speed of 17,000 miles per hour. The interim cryogenic propulsion stage is a 45-foot tall upper stage that offers Orion nearly 25,000 pounds of thrust. Performing 2 separate burns, the ICPS will first raise Orion's orbit and then, later, propel it out on a trajectory to the moon. The ICPS is powered by a single RL-10 engine that will perform these two burns. This storied engine has propelled robotic missions to every planet in the solar system, including Voyager 1 and Voyager 2, the first space probes to reach interstellar space. Orion's service module, provided by the European Space Agency, is the powerhouse that fuels and propels Orion in space. It stores the spacecraft's propulsion, thermal control, electrical power, and critical life support systems, such as water, oxygen, and nitrogen. Orion's crew module is the pressurized segment of the spacecraft, where future crews will live and work on journeys to the moon. Capable of accommodating 4 crew members for up to 21 days, this capsule includes state-of-the-art avionics, innovative crew systems, and the largest heat shield of its kind for entry back into the Earth's atmosphere. Positioned at the top of Orion is the Launch Abort System, designed to pull the crew to safety in the event of an emergency, on the pad or during launch. 3 solid rocket motors can activate in milliseconds, accelerating from 0 to 500 miles per hour in 2 seconds to propel Orion and crew safely away from the rocket. Now fully assembled, Artemis 1 stands at 322 feet. Artemis is no longer a series of separate parts and programs. United together, this is the first of Artemis's arrows, capable of ushering in the next chapter of human lunar exploration. Only together, this mighty system represents all that is possible, all that we are capable of when united around a stunning vision, with each component playing its part in a grander effort. We, the people of NASA and our partners, we, the people of the Artemis generation, all around this beautiful world, will bear witness to what we are capable of. Together, we are going back to the moon.
NASA is preparing for a journey back to the moon, and after that, we're setting our sights on Mars. To get there, we need tons of rocket power coming from our Space Launch System.
When it comes to how much power this thing can push out, this thing is massive.
It's going to be mesmerizing to stand next to this massive vehicle. The immensity of it, knowing that this thing is going to be propelling a rocket into space and around the moon.
Hang on, it's probably best to start back at the beginning. It all started in Promontory, Utah, where Northrop Grumman manufactured each of the segments that make up the rocket's boosters. After a 10-day cross-country journey, the booster segments were delivered to Kennedy Space Center's Rotation, Processing, and Surge Facility, or RPSF. If this all sounds familiar, that's because it's the same facility that was used to process shuttle booster segments, which all came from Utah. Then they're ready to go to the iconic Vehicle Assembly Building, or VAB, where the rest of the motor segments are assembled and stacked on top of the mobile launcher.
So the one thing about this vehicle, of course, it's produced all across the country. Components all come here. They may be built around the country, but they all come together right here in the Vehicle Assembly Building.
Our SLS rocket will generate 8.8 million pounds of thrust to break through Earth's gravitational pull. That's more power than the Space Shuttle and the Saturn V rocket used. Teams with NASA's exploration ground systems are responsible for assembling the boosters that will house the majority of that power. The twin solid rocket boosters, made up of 10 total motor segments, will stand nearly 17 stories when fully stacked. First, teams will inspect and prep the hardware. Next, they're ready to start stacking the segments, a process that takes time, patience, and a steady hand.
Once we have everything done in High Bay 4, we pick up the segment with the 325 crane, pick it up over the 16th floor crossover to where you see it now, and we begin stacking the segments. Each segment, we lift over the 16th floor crossover and stack it. Once we stack it, we put it on top of the segment below, and we put about 177 pins all the way around the whole thing to attach each segment.
And the pressure to perform the operation flawlessly can test the team's nerves.
There's a tremendous responsibility involved with processing flight hardware like this. It's nerve-wracking at times, but it's exciting. There's zero appetite for risk in a program like this.
We have a bunch of shuttle guys that are here to show us along the way. You know, if we get stuck, they're there to guide us. At the beginning of the stacking, it was very nerve-wracking. You know, with each segment that we stacked, a little bit of the nerve comes off. By the third or fourth one, it's easy peasy. You know, we're pushing through, all the jitters are gone, and we're just excited to get finished with it.
With all 10 booster segments now fully stacked on the mobile launcher, there's just one final piece of the puzzle to round out the power needed to get SLS off the ground and send it to space. Core stage. After a 900-mile journey aboard NASA's Pegasus barge, the SLS core stage, the largest rocket stage NASA has ever built, has made it to Kennedy Space Center.
Today is a huge day. This is the last piece of big hardware that we need for Artemis 1 processing. And we've just been waiting a long time for this part of the vehicle to arrive so that we can get going on the next steps of our stacking operations.
Standing an impressive 212 feet tall and weighing a whopping 188,000 pounds, the core stage came all the way from Stennis Space Center in Mississippi. The core stage went through round after round of rigorous testing, including what's called its Green Run series, truly putting its performance to the test. The series involved 8 rounds that looked at systems individually before culminating in pure power. With over 700,000 gallons of propellant flowing through the core stage and its RS-25 engines firing for 8 minutes straight, the successful final test resulted in some big emotions from the team.
We cried, we laughed, and we cheered because it was so emotional to see, the years of culmination coming through.
And that victory did not come without overcoming a few challenges, proving why at NASA we test as frequently and as hard as we do.
And we got to shut down. All personnel.
So we actually did a 1-minute test on the first hot fire test, and then we learned a lot from that. We understood the vehicle more, we made a few changes, and then we got back into our second hot fire test.
There was a lot of joy and workmanship and ownership of being able to work that process and be able to get it done. When we went for the second hot fire and we went for the 500 seconds, that was just pure exhilaration.
Following its arrival at Kennedy, teams moved the core stage into the VAB, where it was lifted by a crane and placed in between the twin solid rocket boosters. Serving as the backbone of the rocket, the core stage will provide more than 2 million pounds of thrust to help send the Orion spacecraft on its trip around the moon.
Essentially, we have these 2 massive cranes that are located inside of the BAB, where we go ahead and we pick 2 points at the end of the core stage, one on the back portion of it and on the front portion of it. We lift it up to the point where we're able to transition it from a horizontal position over into a vertical position. and then essentially bring it way up to the top of the vehicle assembly building and cross it over into high bay 3, in which we ensure that we don't damage any part of the vehicle as it's incoming into its position.
NASA's largest rocket stage, now fully integrated with the twin boosters, is ready to get Orion off the Earth. But it will take one more critical component to give the capsule that extra push it needs to journey tens of thousands of miles beyond the moon. With just a single RL-10 engine, the Interim Cryogenic Propulsion Stage, or ICPS, will provide over 20,000 pounds of thrust to send Orion on the ride of a lifetime. To connect the ICPS with the rocket stack, teams next added the launch vehicle stage adapter to the core stage, followed by the ICPS.
The ICPS is the Interim Cryogenic Propulsion Stage, and essentially it's somewhat of the upper stage of the entire SLS vehicle. And what that will do is propel the Orion capsule along with its service module over to its destination, which at this point in time will be the moon.
But before the spacecraft can be attached to the rocket, teams will conduct a series of tests to ensure all of SLS's components communicate properly with one another, plus the ground systems equipment, the launch control systems, and its software. Adding to the challenge, those methods for testing have changed significantly since the days of the Apollo program. Initially built in the 1960s to house assembly of the Saturn V, the VAB has undergone some major modifications to support several different kinds of rockets and spacecraft, whether they're going into low Earth orbit or venturing to deep space.
This high bay was Shuttle Heritage. Before that, it was Apollo Heritage. So there's upgrades that are still occurring today to include upgrades that will support Artemis II and Artemis III.
When SLS blasts off from Kennedy's Launch Pad 39B, Orion isn't the only thing it will be sending to space. Hitching a ride with Orion are tiny shoebox-sized satellites called CubeSats that were loaded into the Orion stage adapter in Kennedy's Space Station Processing Facility. The extra room in the stage adapter provides a rare opportunity to send those CubeSats to deep space to conduct science and research of their own. And these CubeSats are on tap to study a range of topics, from the moon to asteroids to the effect of space radiation on living organisms. At this point, the stack is nearly complete. All that's missing is the spacecraft itself, which has been in the Launch Abort System facility, getting outfitted with one of the spacecraft's most crucial pieces.
The launch abort system is kind of that pointy solid rocket motor that's at the top of Orion, and it's there to protect the crew in the event of an emergency, so it's a very important system.
Fully integrated with its launch abort system, the Orion spacecraft slowly makes its way to the VAB in the overnight hours. Upon its arrival, teams carefully lift and lower it onto the Orion stage adapter. With this operation, stacking the most powerful rocket the world has ever seen is complete. And what a sight to behold.
We're trying to decide, what does exploration look like in the future when we retire shuttle? You know, what does our nation want to do? Where do we want to go? How do we want to explore? To see it go from those days of words and ideas in people's heads to the 3 programs we have today and the Artemis mission and all the hardware that's been produced in factories ranging from big aerospace companies to little mom and pop shops all over the country and the world. It's unbelievable, and I'm just really proud.
Before SLS and Orion can launch our nation into a new era of space exploration, a series of tests needs to take place inside the VAB, validating the rocket and spacecraft as an integrated system and paving the way for one final milestone: wet dress rehearsal. The 322-foot tall, fully integrated rocket will roll out to Launch Pad 39B for a full test, allowing the launch team to run through a full launch countdown, but stopping just short of firing the engines.
I think we're going to be so proud when it rolls out of the VAB. I will personally be probably crying a little bit because it's such a big event. We worked so hard to get us to the day of rolling out. I'm probably going to be bawling when we launch it. See it through my tears because it's just a culmination of so much work from everybody.
We owe the advancement of science and research and technology to what we're doing here. And this is a big opportunity for us as a nation to reclaim our spot at the forefront of human space flight and exploration.
Artemis is going to be a major part of history. It most definitely is going to rock the space industry when it flies. This program is going to go to the moon. It's going to go to Mars. We need that. This country needs that. This world needs that.
I'm so excited. It's going to be a lot of work ahead of us, but Artemis 1 is going to surprise everybody.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.
We have been given the scientific knowledge, the technical ability, and the material to pursue the exploration of the universe.
There is one place where we're seeing climate change unfold faster than anywhere else on Earth. Here. In fact, temperatures in the Arctic and boreal regions are rising nearly 4 times as fast as those in the mid-latitudes. That's why NASA has teamed up with local partners to better understand the vulnerability and resilience of these ecosystems, while also gathering valuable data that will help future Earth-observing satellites. From space, air, and on the ground, we'll see how scientists are piecing together the story of the Arctic, from how it is changing to what that means for our planet. Because as they say, what happens in the Arctic doesn't stay in the Arctic.
PPA is engaged. And we're radiating.
One of the best ways to track how an environment is changing is to observe it from above. But where weather and vegetation can make it difficult to see the ground with the naked eye, specialized radar can pierce the clouds to give us a crystal clear look at the landscape. This special device, weighing nearly 1,000 pounds, collects data about soil moisture, vegetation, permafrost, and other environmental processes on the ground below. In fact, it's so precise that NASA developed a special system for pilots to fly the exact same flight path year after year to get an accurate reading as to how a landscape is changing over time.
So with the airborne data, we can target exactly where we want to go and exactly when we want to go there, and we get very high resolution data, so we can have a really clear picture of what's on the ground.
That's Dr. Liz Hoy, senior scientist for NASA's ABOVE mission. ABOVE has spent the last 7 years studying environmental changes in the Arctic and boreal regions. The mission uses satellite, airborne, and ground data to get a complete picture of what is unfolding in these ecosystems.
So our satellite data gives us a very broad picture of what's happening all over the landscape. And then with our airborne data, we can target specific locations and times when we want to get imagery. And then we can compare both our satellite and our airborne data with what's happening on the ground when we have teams actually out on the ground making measurements. And putting all that together is really where we get a lot of the power of what we're able to study.
And it all gets put together in Alaska. On the ground, these large dishes are used to communicate with NASA's Earth-observing satellites. Here, the data is downloaded and made public, which helps scientists connect the dots between what we see from space and on the ground. But why are these dishes in Alaska?
So the reason why a station like ASF is built in Alaska is because Earth-observing satellites, if you think of their orbits, they converge in the polar regions. So in Alaska, we can see the same satellite more often than in the lower 48.
In fact, this facility is in the perfect position to receive data from one of NASA's latest Earth-observing missions. NISAR is an upcoming satellite that will be launched by NASA in collaboration with the Indian Space Research Organization. It will use radar similar to what is flown on NASA airborne missions, like for ABOVE, to measure fine, centimeter-scale changes in Earth's surface.
What's interesting and unique about NISAR is that it's going to cover the globe regularly every 12 days. And it's going to do it at a wavelength or frequency range, so-called L-band frequencies, that are very useful for doing Earth observation. L-band will allow us to study ecosystems changes and deformations of the Earth's surface with higher accuracy and better spatial coverage than we can with current systems in space.
And in the Arctic, some of the most pronounced environmental changes satellites can observe are happening right down the road. And it all starts with this stuff. Permafrost is frozen earth, be it ice, soil, or even organic material that has been frozen for 2 or more years. Most of Alaska and northern Canada has permafrost beneath a thin, active layer of soil. Problem is, when permafrost does thaw, it can wreak havoc on infrastructure and upend ecosystems.
Not all permafrost contains ice, but here in interior Alaska, we have frozen soils with massive amounts of ice. There are very large ice wedges as big as garages. And so when that ice melts, the ground surface collapses and the sinkholes can fill with water. When that happens, new little ponds form, thermokarst ponds.
And as thermokarst ponds form, microbes in the soil feast on the newly thawed organic material, releasing methane into the atmosphere, an extremely potent and flammable greenhouse gas. These newly formed thermokarst ponds give us an insight as to what is going to happen in the future.
What we're seeing at this lake is that the emissions are 10 times higher than the rest of the lakes and wetlands in the Arctic. And it's being fueled by thawing permafrost.
Scientists are working with ABOVE and NASA's UAVSAR radar to study how these lakes are evolving as the climate continues to warm. But it's not just thawing permafrost that is reshaping the Arctic. It is also wildfire. In higher latitudes, forests are adapted to burn about once every century. But with warmer temperatures comes more fires. And why is this? Partially because of this stuff called duff, forest debris that slowly builds up on the forest floor, about 1 inch every 17 years. And because of the cold winters, it doesn't decompose.
It doesn't have roots, so it's completely dependent on relative humidity for moisture. So it actually dries very rapidly in warm, dry conditions like we often have here in the summer.
Which means with warmer temperatures, duff becomes a potent fuel for fires.
Most Alaskans are vulnerable to wildland fire, and with climate change, it seems that the imprint on the landscape is growing, and so more and more communities are vulnerable.
when a wildfire comes through, what we're really seeing is it's not just the trees that are burning, but it's the soil layer that's burning as well. And so when that fire comes through and it burns that soil layer, it's like you're taking off the lid of a cooler where everything is frozen below. And so as that soil comes off, then we start to see the ground start to thaw, and permafrost is thawing there. And so as we see those changes happening, we're actually creating more climate change over time. So wildfires are releasing carbon gases into the atmosphere, and then as permafrost thaws, it too is releasing carbon gases into the air, which then can create warmer conditions, which can allow for more wildfire and more thaw. So you really see this cycle that continues up in boreal forests and Arctic areas over time.
So the bad news is that as human-caused climate change continues to impact the Arctic and boreal landscapes, those living both near and far will continue to feel its effects. But the good news is that there is a team of dedicated scientists across a variety of disciplines that are working together to give us a complete picture of these ecosystems and how they are changing. Because this collective knowledge is key to understanding how we can lessen our impact.
Have you ever heard that something called the ozone layer is thinning? Or that your aerosol hairspray is what's causing it? Or that it leads to more severe sunburns and UV rays? This is referring to the ozone hole. But what exactly does it all mean? Welcome to Ozone 101. The ozone hole's proper name is actually the Antarctic ozone hole, because when it forms over Antarctica. But before we get into what that is, let's first talk about what ozone itself is. Ozone is a gas comprised of 3 oxygen atoms. About 90% of the Earth's ozone exists in the stratosphere, the layer of the atmosphere that extends from 8 to about 30 miles above the Earth's surface. In fact, the stratosphere is often referred to as the ozone layer. Ozone acts as a sunscreen around the Earth, filtering out harmful ultraviolet radiation, or UV rays, which are mainly absorbed in the stratosphere. Without an ozone layer, UV radiation would sterilize the Earth. With a damaged but still present ozone layer, there would be more sunburns, more skin cancer cases, increased cases of eye damage, the wilting and loss of trees and plants, and significantly lessened crop yields. Suffice it to say, ozone is pretty important for the planet. So what causes the ozone hole? There are several major factors that together lead to the destruction of ozone, thus creating the ozone hole. Those factors are 1. Very strong winds around the South Pole, or the polar vortex. 2. The sun's rays. 3. Chlorine and bromine compounds from ozone-depleting substances. And 4. Cold temperatures below -109 degrees Fahrenheit in the stratosphere, which form a specific kind of cloud, polar stratospheric clouds. The polar vortex forms in the southern hemisphere stratosphere during the winter as temperatures drop. And when sunlight returns to Antarctica in late winter and early spring, temperatures are still cold enough to form polar stratospheric clouds, and now there's also sunlight. Chemical reactions take place on the cloud particle surfaces, converting unreactive forms of chlorine and bromine into reactive chemicals. The vortex acts as a sort of container, confining the contents of the Antarctic stratosphere within its bounds, allowing the reactive chlorine and bromine compounds to destroy ozone molecules. That's when depletion can occur on a large scale. With the presence of sunlight, the reactive chlorine and bromine compounds produced during winter begin to deplete ozone molecules by stealing one of their oxygen atoms, leaving just oxygen gas, or O2, in its wake. As long as the polar stratospheric clouds are present, these reactions will occur over and over again, until the ozone is nearly gone. This forms what we call the ozone hole, but that's really a misnomer. It's actually more of a thinned layer. In mid to late spring, the vortex begins to break up, and the polar air depleted of ozone is mixed back into the rest of the southern hemisphere. The ozone hole is gone. Ozone depletion has still occurred, it's just no longer all concentrated in one small area. It's spread around the atmosphere. So why is the ozone hole bigger and longer lasting in certain years? Well, it all comes down to weather. Just like some winters are colder and longer than others on the Earth's surface, the same goes for weather in the stratosphere. If the Antarctic stratosphere stays cold, the polar vortex and the ozone hole within it will persist. And in years with cold springtime temperatures, the polar vortex and the ozone hole are large. Make no mistake, ozone depletion is not a natural thing. It stems from human emissions of chemicals called chlorofluorocarbons, or CFCs. In the early 1900s, refrigerators used toxic gases like ammonia and methyl chloride as refrigerants. Unfortunately, this led to fatalities as the toxic gases leaked out of the appliances. So the search began for a non-toxic and non-flammable chemical that could be used as a refrigerant. Thus, the CFC was born. There are many types of CFCs, but the two most common are CFC-11 and CFC-12. In the 1930s, the production and consumption of CFCs began to skyrocket. By the early 1980s, over 300 million pounds of CFC-11 alone were being released into the atmosphere each year. Then, in 1985, British researcher Joe Farman and his colleagues published their research on large seasonal ozone losses over Antarctica. Thanks to the combined efforts of the quick-acting science community, industry, and policymakers, the Montreal Protocol was signed in 1987, restricting the production and consumption of CFCs. Every nation on Earth has now signed the Montreal Protocol. So, for the record, your hairspray and aerosol deodorant hasn't been harming ozone since these laws went into effect in the 80s. But why do we still see an ozone hole today? First, CFCs have lifetimes of 50 to 100 plus years, and it will take some time for the concentration of CFCs in the atmosphere to drastically decline. Second, there are still CFCs being released into the atmosphere today. For example, as an old refrigerator or air conditioning unit deteriorates in a landfill, the CFCs within are slowly released. From the time a CFC is released into the air, it takes about 5 years for its impact to be felt over Antarctica, where depletion will occur. The CFCs emitted at the surface eventually rise into the tropical stratosphere. The ozone in the stratosphere blocks most of the sun's UV radiation, so the CFCs have to rise above most of the ozone layer before sunlight can then break them down. Once they get high enough, solar radiation releases the chlorine, most of which eventually goes into ozone-safe forms like hydrochloric acid and chlorine nitrate. When these compounds make their way to Antarctica, those chemical reactions start up. And if you're wondering why Antarctica, these reactions are unique to the polar regions because of their extreme low temperatures and presence of polar stratospheric clouds. One chlorine atom can destroy thousands of ozone molecules, and millions of tons of CFCs were pumped into the atmosphere from the 1920s through the early 1990s. As CFC concentrations in the atmosphere continue to decline, the ozone hole is expected to gradually become less severe, and scientists expect the Antarctic ozone to recover back to healthy levels around the year 2070.
On September 3rd, the 4-person crew of our SpaceX Crew 6 mission, including NASA astronauts Stephen Bowen and Woody Hoberg, climbed aboard their SpaceX Dragon spacecraft and undocked from the International Space Station. They returned to Earth very early the next morning, splashing down safely in the waters off the coast of Jacksonville, Florida. The international crew contributed to hundreds of experiments and technology demonstrations during its 6 months in orbit. The no earlier than October 5th targeted launch date of our Psyche mission to a metal-rich asteroid is less than a month away. The Psyche spacecraft will have a hitchhiker on the trip, a laser transceiver for our Deep Space Optical Communications or DSOC technology demonstration. DSOC, the agency's first test of high-bandwidth optical communications beyond the moon, aims to show how lasers could increase data transmission rates far beyond the capacity of current radio frequency systems used on spacecraft today. Members of our Mars exploration program and several international partners recently went on a field expedition to the Western Australian outback to study some of the oldest confirmed fossilized life forms on Earth that may be relatable to Mars. Both planets may have had similar pasts, so learning more about the evolution of Earth may help us understand what we find now and in the future as we search for signs of ancient microbial life on Mars. An MD-90 airplane was recently flown to Boeing's Palmdale, California facility to be converted into the X-66A experimental aircraft for NASA's Sustainable Flight Demonstrator project. The X-66A, which will utilize a fuel-efficient transonic truss-braced wing configuration, supports the U.S. goal of achieving net zero aviation greenhouse gas emissions by 2050.
It's extremely exciting. In my lectures, there are always young people in the audience, and they always want to know when they're bringing it back, you know. And I always say, I don't think ever. I think NASA, they realizes that they have two marks, so to speak, but somehow they can be made to coordinate.